Latex is a natural substance derived from the sap of rubber trees.
The rubber tree, known as Hevea brasiliensis, is the primary source of natural latex.
Latex has been used by humans for thousands of years in various forms. The journey from latex to medical gloves involves several complex manufacturing steps.
Natural latex contains proteins, lipids, sugars, and rubber particles. A single tree can produce latex for up to 30 years.
Industrial filtration system removing debris from liquid latex. The latex is then filtered to remove impurities and bark particles. Digital screen showing 60% dry rubber content reading. Concentrated latex typically contains 60% dry rubber content.
Stabilizers and preservatives are added to extend the shelf life of liquid latex. Compounding is the process of adding chemicals to raw latex.
Sulfur is added to latex as a key vulcanizing agent.
Antioxidants are added to protect gloves from degradation over time. Pigments may be added to give gloves their characteristic color. Medical gloves are made through a process called dipping.
Hand-shaped molds, called formers, are used in glove manufacturing.
Multiple dipping cycles building visible glove layers. Multiple dipping cycles build up the required thickness of the glove. The number of dips determines the final thickness of the glove. Medical gloves typically require 3 to 5 dipping cycles. Vulcanization cross-links the rubber polymer chains for strength and elasticity. Stress test stretching glove material showing tear resistance. Proper vulcanization gives gloves their tear-resistant properties.
In this comparison test, the weak glove tears easily. Under-vulcanization leads to weak, easily torn gloves.
Conveyor moving gloves into large water tanks. After vulcanization, gloves undergo a leaching process. Leaching removes residual chemicals and water-soluble proteins from gloves. The leaching process significantly reduces latex allergen levels.
Polymer coating is another method to improve glove donning.
Powder-free gloves are increasingly preferred in medical settings.
Powdered gloves were once common, but have fallen out of favor.
Cornstarch powder was historically used as a lubricant inside gloves.
Air inflation tests evaluate the integrity of each glove. Tensile strength testing measures how much force a glove can withstand. Elongation testing evaluates how much a glove can stretch before breaking. Gloves must meet international standards set by organizations like ASTM and ISO. Medical gloves come in several types: examination, surgical, and chemotherapy gloves.
Deep breath in, please.
Okay, sounds clear. Now just relax while I examine your abdomen. Everything seems perfectly fine.
Surgical gloves are sterile and used in operating rooms. Sterile gloves are individually packaged to maintain sterility.
Latex allergy is a significant concern in healthcare settings. You're having a reaction. I'm giving you epinephrine. Breathe deeply for me.
Hospital staff frequently wearing gloves during shifts. Healthcare workers have higher rates of latex allergy due to frequent exposure. Manufacturing process showing reduced protein latex gloves. Low-protein latex gloves were developed to reduce allergy risks.
Display of synthetic gloves in various colors and materials. Synthetic gloves were developed as alternatives for latex-sensitive individuals. Nitrile rubber is the most popular synthetic material for medical gloves.
Nitrile gloves offer excellent chemical resistance compared to latex gloves.
Neoprene gloves provide good chemical and biological resistance. Synthetic gloves have largely replaced latex in many healthcare facilities.
The manufacturing process for nitrile gloves is similar to latex gloves.
Nitrile gloves are inherently protein-free, eliminating latex allergy risks.
The nitrile glove market has grown dramatically over the past 2 decades.
Gamma radiation is commonly used to sterilize surgical gloves.
Ethylene oxide gas is another sterilization method for gloves.
The inner package maintains sterility up to the point of use. Expiration date printed clearly on glove package. Expiration dates on glove packages indicate the sterility guarantee. Medical gloves are available in sizes ranging from extra small to extra large.
Proper glove sizing is critical for dexterity and protection.
Glove sizing is typically based on hand circumference measurements.
Some gloves are designed to be ambidextrous for convenience.
Surgical gloves are available in half sizes for precise fit.
ISO standards provide international benchmarks for glove quality.
Check the calibration logs for the robotic arm over there. We need to ensure compliance with the new safety standards.
Got it. I'll cross-reference with the maintenance schedule.
The checklist was
Billions of pairs of gloves are disposed of globally each year.
Natural latex gloves are biodegradable under the right conditions. Synthetic gloves, like nitrile, are not easily biodegradable.
The COVID-19 pandemic created unprecedented global demand for medical gloves.
Yes, I see the delay. But we desperately need those masks and gloves by Tuesday, or the hospitals won't have enough.
Gloves protect healthcare workers from exposure to blood and bodily fluids.
Just a quick pinch, almost done. These gloves keep everything sterile, so you're safe.
Good to know. Thanks, Doc.
Proper glove donning and doffing technique is essential to prevent contamination.
Watch the vitals. I need better visualization here. Suction ready, doctor.
Gloves should be inspected for defects before use.
As a crucial safety measure, first remove all hand and wrist jewelry. Then, you can safely put on your gloves.
Nails should be kept short to prevent glove puncture.
Hand hygiene should be performed both before and after glove use.
Watch the vessel stabilization.
Holding steady, doctor.
Good. Ready for the approximation stitch.
Thinner gloves generally provide better tactile feedback.
The balance between protection and sensitivity is a key design challenge.
Advanced Material Science Lab developing stronger, thin gloves. Advanced formulations allow for thinner yet stronger glove materials. Chemical permeation testing evaluates how quickly substances penetrate gloves. Comparison chart of glove materials resisting different chemicals. Different glove materials offer varying resistance to different chemicals. No single glove material is resistant to all chemicals.
These new gloves are remarkably stiff, Miss Ada.
Yes, Doctor. Shall I assist with the left?
If you please.
Forceps, Doctor. And mind the sutures. They must be perfectly taut.
Early gloves were thick and reusable, quite different from modern disposables.
The development of latex dipping technology transformed glove manufacturing.
See that these gloves are secured tightly. And the clamps, please.
Yes, doctor. Right away. The tensile strength is remarkable at this thickness.
And the elasticity held steady throughout the stress test.
This material exceeds our expectations.
Eco-friendly biodegradable synthetic glove concept. Biodegradable synthetic materials are being explored as eco-friendly alternatives.
Nanotechnology may enhance glove barrier properties in the future. Self-repairing glove concept, sealing tiny puncture automatically.
The transformation from latex to finished medical glove is a remarkable industrial process. Medical gloves remain one of the most important tools in modern healthcare.
Ongoing innovation in glove technology continues to improve safety for both patients and healthcare workers.